Well, this is an interesting circuit board. I figured I'd show you. It was donated there by Dwayne. We thought it was maybe a COM port, printer port card, but it's far from a printer port. Got a DB25 on there, so kind of think it was a printer port expansion card, but that's not the case. It's actually a Kansas City tuner / tracker. Apparently, this is a board that's used for radio tuning, controlling rotors and whatnot for satellite communications. And there's a little write-up on eham.net about this board. They say, let's see, the Kansas City Tracker Tuner is an 8-bit PC board which will operate an open ISA slot in IBM-compatible computers ranging from XT to Pentium systems. It does not use any hardware interrupts, parallel ports, or serial ports. The card occupies 4 consecutive I/O addresses, starting at the address specified on the board's dip switches. It has its own DB25 type port, which is used to connect to both a rotor controller and either a dual band radio or two single band radios. An 8-foot cable is provided with the DB25 connector on one end and an 8-pin DIN connector on the other. This cable can be used as is to connect to a Yaesu or Kent Pro 5400B, 5500, 5600 rotor controllers, or it can be modified using instructions provided for other type controllers. The KCT interfaces with the rotor controller in 2 ways. First, it requires input from the elevation and azimuth potentiometer to determine the position. This must be a form DC voltage that varies from 0 volts to 5 volts. As the antenna moves from one end of travel to the other, it then uses an AD converter to generate voltage's position table. It can send the antenna array to any specified position. Second, the KCT has 5 outputs which can activate the controller's up, down, left, right, and brake release inputs. These lines can pull desired input to ground, to case antenna motion in the corresponding direction. Manual control through the controller switches is still possible. The Yaesu Kent Pro controller can be driven directly by the TTL 30 mA outputs. The rotor interface, which is now standard on the KCT, expands its current syncing capability to 300 mA and is used to drive external relays. To use the KCT with a controller other than the Yaesu Kent Pro 5400B, 5500, 5600 series, you will need to purchase and install your own 12-volt relays, such as those available at Radio Shack, between the KCT and your controller. Instructions for the process are included in the user's manual. What else does this thing do? Instructions are provided for connecting a user-supplied cable to the DB25 end of the KCT cable, for interfacing to either serial port or mic click input of the radio. Using the tuner function requires the use of separate satellite tracking programs such as QuickTrack or WISP. Some programs that support the KCT do not support the tuner option. There's no need to purchase a TTL or RS-232 converter for your radio. The KCT can be switched to either type output. When the Kansas City Tracker / Tuner is used with one of these programs, the system can be set up automatically follow a schedule of satellite passes and to send and receive data unattended. The following radios are supported by tracking programs that use the DOS KCT TSR, the Kenwood TS711, TS811, TS790, the ICOM IC275, 475, and the IC970, single band control, and R7000, Yaesu 736, and the FT767. Additional radio support by various satellite tracking packages which supply their own custom KCT drivers. These may operate under Windows 3.1, Windows 95, Windows 98, or Windows NT. This is the reviews I read. These come up rarely, but are highly sought after. So, cool. Well, that's, I thought this was an actual printer, no printer board. But hey, it's far from it, so let's have a close look at this board. Crystal, 5.0588 megahertz. Let's just go through the whole board so you can see everything that's on it. There's the two dip switches. I'll widen this out because these ICs are a bit larger. If anybody out there on my channel, subscriber list, would be interested in the circuit board, let me know. This circuit board is more than I thought it certainly was. Anyways, and oh yeah, and in case you wonder what the dip switches on this one is set to, 1, 2, 3, 4, 5 are turned off, 6, 7, 8 are turned on, 1 through 6 turned off, 7 and 8 are turned on. So, cool. That's more of an interesting board than I thought it was. Thanks for watching.